Yeah, we definitely want it doing that. Okay. Cool. So again, thanks for joining us today. I'm lmotl. I'm a UX designer, and this is Antal. He's a backend developer. We'll be talking to you today about predictive UX, kind of what it is, our experiences with it, and what how to potentially implement it. So we both work at a Drupal agency in Denver called Elevated Third. We are completely Drupal focused and have been in business for over a decade. And the reason we got...
Sorry, can you speak up a bit?
Sure, of course. Yep. So what got us interested in this topic originally was actually a client who asked me, what does UX look like 5 years from now? And I was like, that's a great question. I've never really thought about it. So that happened about a year ago, and I started doing some research, and I came across this this concept of predictive UX, and I started talking to Gurwinder about it, and we started having some really good conversations and wanted to explore it a lot more, and that's kind of how all of this came about. It really caught our attention, and we wanted to start having bigger and bigger conversations about it and see what we could do with it. So to start, what is predictive UX? Really, it's a design pattern that uses statistical techniques to predict future user behaviors. It's really the intersection of machine learning, the Internet of Things, and UX design. And another term you'll hear a lot for it is anticipatory design. Today, the terms are really interchangeable, but today we're just going to refer to it as predictive UX. But if you come across it, it's essentially the same thing. And when we're talking about predictive UX, we should probably start with personalization, which I know is a pretty big buzzword right now, especially in the marketing industry. It's a really exciting concept. If you're not familiar with it, it's dynamic content that can adapt to different users on the site. But right now, it doesn't use machine learning to do that. It's a lot of manual work, but it is using data. And really, you can see that doing that would be a huge benefit to a marketer and a user, because essentially you're getting users more relevant, direct content faster. And what predictive UX is basically a smarter version of that. It can make informed decisions on a user's behalf, which is really cool. And so to sort of give you an example of how this theoretically could work, is to sort of frame it around a problem of, what's for dinner? So picture yourself trying to figure that out. I know this scenario happens in my house pretty much on a weekly basis. My husband and I constantly arguing about it. We get home from work, we're tired, we're hungry, we don't want to cook, we don't want to go out maybe somewhere. So instead we probably go on something like Grubhub or DoorDash, and we try to figure out from a couple hundred different options what we want based on a bunch of different metrics of how we're feeling at the moment. And this is really where predictive UX can shine, because while it's convenient, you're having to still make a lot of decisions and sort of run through and do a lot of your own research. But if you could use predictive UX to reduce that cognitive load on yourself and free up your time, that would be awesome. So some of the things you could potentially do to reduce the number of options that you're seeing and get to the results that you want faster without really having to do much yourself would be having a machine learning algorithm start to parse out those options and make better recommendations based on your history or the time of day or even the season, and just have multiple metrics layered on top of each other to do that. So behind me, you'll see a screen of logos of companies that are already semi-predictive. I'm sure there's a lot of Netflix and Spotify users in this room. You're probably familiar with, Netflix is giving you recommendations based on your past history. Spotify is doing the same thing. They're curating things for you. They're very transparent about it and even send you an analytics report at the end of the year showing you all of your metrics, which I actually really enjoy. And Nest actually is probably the one that's closest to being fully predictive. It can actually, after it's gathered enough data based on your preferences, and how that aligns with other metrics like the time of the day and the season, it can actually start setting the temperature for you without you even having to do anything. It'll just automatically update in your house. So that's pretty amazing. So now that we've talked a little bit about what predictive UX actually is, Gurwinder is going to talk about a little bit of background on machine learning and how that would power the end user experience.
All right. So with machine learning, we're going to keep it kind of simple, kind of high level, not go into the math so much, just to see how things work, get a general idea. Now, machine learning is a relatively new topic, so you'll find everything from informal definitions like this all the way up to very complex mathematical expressions. So we are simply defining it as the science of getting machines to do things without explicitly programming them. Now, how do you do that? You begin with defining your machine learning problem, and all that means is you define your problem, but you also define how you measure the success of an algorithm, or how do you measure, or how do you find out whether your machine is actually learning, right? The next step is to collect data, and it's a subset of machine learning techniques which use training data, where you give some data to a model, to a machine, and then it builds a model using that. So you want it to be in the right format based on what kind of a problem you're trying to solve. So if you're building something like the Amazon Echo or a Google Home, you're solving a natural language processing problem. So your training data in those cases will be the user input, which is what they said, and the user intent, which is what they meant. In other cases, like a recommendation system, your training data could contain the user identifier and then a preference that they have or the rating that they gave to an item, something like that. And then your machine learning algorithm is going to build a model, and then you use that model to predict the values of unknown inputs. So let's look at an example. And we're going to go with a simple one here. And I'm defining my machine learning problem as predicting the price of a house given its square footage. Now the next step, where I'm getting my training data, I have all this made-up training data. On the horizontal axis is the size of the house that I'm considering, and on the vertical axis is its price. So now that I have this training data, I'm going to give this to my machine learning algorithm, and I'm kind of going to generate a model, and that process is what we call model fitting. Now there are cases where you have to really consider how you should build a model out of this. In this case, it's kind of easy to see that a straight line fits this model relatively well, so that is what we go with. And there are a couple of problems here. There's something called overfitting, where you make your model pass through every data point, and that gets really slow and very computationally heavy. On the other hand, you could have underfitting, where you don't pay enough attention to your model and the data points, and in those cases, your results are going to be inaccurate, right? So in this case, I'm simply minimizing the distance from my data point to the model, which is a fairly common technique called gradient descent, and I get a straight line as my model. And then now that I have my model, I can use this to predict the outcome of an unknown input. So as you can see, I don't have data for the price of a house, which is 3,000 square feet, for example, but I can look at my model and kind of figure out that it's going to be about $460,000. Is this going to be 100% accurate? Probably not, but it's a decent estimation. So the example that I just showed you is a type of machine learning technique called regression, and that's where we predict the quantity of something. And for our use case, the meal ordering app kind of situation that we talked about, it is not a regression problem, but it is a recommendation problem. Now the example we talked about was more for simplicity, more to give you an idea of how a machine can predict something for an unknown input without explicitly programming it. But for recommendation systems, it's a completely different subclass, slightly harder to visualize, but it's a subclass of machine learning techniques that aim to predict a user's preference. Now, recommendation systems typically come in two flavors, and then a combination of those. So the first one is content-based recommendation, where the focus is the item itself that you want to recommend, and the features of that item. So, for example, you go on Netflix and you watch a comedy movie, and then you might see like more comedy movies coming up in your recommendations. So that's an example of content-based filtering, where you're picking the genre of the movie and then recommending other movies of the same genre. right? An alternative to that is collaborative filtering, where you don't really consider the item or like what you're recommending. You focus more on other users who have the same tastes as you, and then you recommend items that those users like. And a good example of this is Amazon, I think, where you see that section where you can see other users who bought this thing also bought these other things. So that's an example of collaborative filtering. And collaborative filtering does happen to be the more commonly used because it's more robust. And it is also very common not to have just one of these. A lot of companies typically will layer on multiple machine learning techniques to kind of build their own sort of recommendation systems. And those are called hybrid recommender systems, which I think is the more practical and common use case these days. So now that we kind of have an idea of what machine learning is, you have a general overview, let's look at some UX principles, and then we'll kind of show you how all of that comes together in a short proof of concept that we made.
So we've talked about what predictive UX is and a little bit about how it kind of works in the background, or how it could potentially work. But I want to kind of start this off of like why predictive UX. And Laura Bush wrote, "This is about putting cutting edge technology at the service of users so they can dedicate more time to the high level processing tasks that modern living requires of them." And we keep asking a lot more of our users with every like sort of technological innovation that people come out with. So I think this is a really great use case for why you would want to use it. I think the thing to always remember, at least right now with predictive UX, is that there is a challenge. Like, algorithms are binary and they can't understand the qualitative side of user decisions. Like if I go online and order a bouquet of pink carnations, the algorithm only knows what I ordered. It doesn't know that I ordered them because they reminded me of my mother. That's a problem that people have been trying to solve since the invention of the analytical engine, and Ada Lovelace created the first computer program. They've had think tanks working on this for decades, and it still hasn't been solved. I'm sure there's still people here in the Bay Area working on this exact problem.
To add to Lauren's point there, if you look at this example over here, and if you look at the image on the left, there are two squares marked A and B. The A is not very visible, but looking at this, what do you think, which square do you think is darker? And we already given you a spoiler on the right, but on the left, it does look like the square marked A is kind of darker than B, which is actually not true, because both of those squares are the same shade. And on the right, you can see that when in isolation, they're actually the same color. But on the left, they do look different. And then that kind of drives home the point of how bias and context in human perception kind of win over data and analytics.
So the first principle I want to talk about is really how the front-end UI can help support sort of the back-end, like, predictive algorithm portion. And I think this is a pretty straightforward one. Creating minimal interfaces with just the right amount of design elements is really critical. You want to be creating like highly scannable content that's easy to read, like layouts that are going to help aid reducing that cognitive load along with the algorithm, so that it's just really helps supporting it. The second principle is designing against the experience bubble. And I think that this one is probably the most important one. It's definitely the most dangerous aspect of predictive UX. As Eli Perriger wrote, we like to be surrounded by the familiar and by information that confirms what we already believe. But it's a problem because it means you're less likely than ever to be confronted with information that challenges your views or gets you out of your comfort zone. Your own point of view follows you wherever you go. So essentially, what it has the power to do is create a state of intellectual isolation, which has already happened. I mean, I'm sure a lot of people are familiar with the 2016 elections and what happened with Facebook, where people were sitting in their feeds in a complete feedback loop with data that was being fed to them based on their preferences and what they were clicking on. And they weren't seeing any other viewpoints outside of what they were already attracted to. And a lot of people were shocked with the outcome as a result. So I think that's a really great real-world example of how something like this can really affect your entire perception of reality. I think some companies are already attempting to help disrupt people's feedback loops. Like Grubhub's already introducing a mix it up feature where you can click on that and it'll try introducing new things to you. So it's user action to do that, but it's making people aware that maybe they should try to kind of get out of the norm or what they're always doing. Our demo, which Gurwinder will show shortly, uses a similar feature, as well as something we're referring to as like a healthy mode. And that basically would allow a user to add a layer in to introduce disruptors to them periodically so that it can further help reduce the chances that they'll be stuck in that kind of feedback loop. So the final principle I want to talk about today is predictive is not the same thing as control. People want to still drive the bus. They just want a GPS to tell them where to go occasionally. And I think that users still need to feel like they're doing that. I think a really good example is made by Joel van Bodegraven, where he asks you to imagine that you have an application that helps you manage your finances and is helping you try to save more responsibly and spend more responsibly and things like that. So imagine you have this application and you're out with your friends, you're having a couple beers, whatever, and you get a notification on your phone that states you can have one more beer based on your expenses and your monthly spending pattern. All other orders will be declined. I know I would be pretty frustrated by that unless I had explicitly opted into that. I think the point of that kind of example is that users do require some control over the level of automation you're giving them. So it's a really good idea to give them options. Maybe it's not like the primary thing they see, because of course this is about predictive UX and giving them, in this context, giving them better recommendations, but still allowing them to find ways to really do some self-exploration. So in this UI, we would want to do that by allowing people to filter by cuisine and maybe explore that way, or they can maybe go to a more filtered searchable view, or they can manage their preferences, their profile, and turn off that healthy mode. It's not being forced on them. So now that we've kind of talked about the UX principles, Gurwinder is going to talk about whether this can be built in Drupal.
So, spoiler alert, yes it can. We did it. And before we go into the actual implementation of things, let's look at why Drupal is a good fit for this. And all of us have had some kind of experience with Drupal, I'm sure, and we all know it's a content management system. It gives you really easy data storage, so that's always helpful. The second one, slightly more controversial one, it has a relatively smooth admin experience. People disagree, maybe it doesn't look too great, but it gets the job done. You don't really have to be technical to use the admin experience, right? Finally, what I like the best about it is Drupal 8 makes it so easy to integrate with other systems that you can basically connect to any kind of system that gives you an API and an interface. Now, talking about let's talk about this first. So I used a tool called Apache Prediction IO, and I have links to all of this at the end of the slide deck. But this is an open source machine learning stack, and when I say machine learning stack, I mean it gives you everything that you need to get a machine learning engine up and running. It gives you storage, it gives you algorithms to choose from, it gives you a bunch of templates that you can choose from. And Prediction IO, interestingly, also has a full template gallery that you can see on the right, and depending on the kind of problem that you're trying to solve, so be it recommenders, be it classification, be it regression, you can find a template that suits your needs. All you need to do is just download it, you get Prediction IO set up, you download a template, customize it if you want to, and then just run it. That's all you need to do. And then when you do run it, you can deploy it as a web service, so all of these recommendations that you're getting, or all of the results that you get out of your model, you can access all of them through a simple REST API. And one thing I found helpful about Prediction IO was that it also gave me a lot of client libraries. So PHP, Java, Python, it has a lot of them. So you can just use them simply and not even use the API. So let's look at the high-level architecture of Prediction IO a little bit. On the left, you have your website or your application. And on the right, this little blue circle here is Prediction IO. And that, on a high level, has two components. One is your event server, which is going to gather all the data, and it's going to store all of that data. And then it's going to provide it to the engine. And this engine is what actually contains your machine learning algorithm. And it's going to crunch all of that data, process it, and then put it up as a REST API. And then you can just query that REST API for recommendations. So now I'm going to draw your attention to the event data that's over there, and that's where we talk about explicit and implicit data. Explicit data is where the users explicitly tell you what they like. So for example, Netflix has a thumbs up, thumbs down system where you can tell explicitly, hey, I like this movie, give me more of this kind of thing. The other one is implicit data, which happens to be more the bulk of what is useful in actual real world systems. And implicit data is what you can already get, what's already available, and the user is not explicitly telling you what it is. So for example, where in the explicit case, I was rating a movie that I like it or not. In the implicit case, maybe I binge watch 5 seasons of American Horror Story in 3 days, and maybe I like this show. Maybe. So that's kind of an example of implicit data where I can figure out that, oh, this is what the user likes. So at this point, let's look at an example. Let's see the implementation that we did. It is by no means a complete implementation, but we wanted to see if it's even possible, how easy it is, if anybody can do it, if we can keep it all open source, because I know platforms like Amazon and IBM also give you like ready-made setups ready to go, but I know a lot of them you have to pay for. You don't really have a lot of control over them, not a lot of full customizing that you can do. So let me check if my engine is running, and it is. I've had it go down on me a couple of times, so just making sure. So this is an example Drupal 8 site, where once you go to the site, you see a list of restaurants simply sorted by proximity. You can see what the nearest one to you is. You can order if you want. But the interesting things happen when you log in. And as you can see, once I logged in, I have recommendations that are customized to me. So let's look at the bottom down here. As you saw in the slides before, it has a list of my favorite cuisines, and all I'm doing what I'm doing to get that is sending an API query to my machine learning server. And once I do that, it returns to me a ranked list of recommendations for me. So that I really don't have to do much except just display it. And then based on my favorite cuisines, I put some restaurants belonging to that cuisine type. And then, so the event data, so when you go to a restaurant and you place an order at that restaurant, I pick up all that data and I send it to the event server, again through the API. So that's how the data is being collected. And once you gather all of that data, you can go to your machine learning server. There are 2 simple commands that Prediction IO gives you to train and deploy your engine. And once you do that, you're all set to go. You go to your home page and you get all your recommendations. And coming to the UX principle part of it, we do have a disruptor here that allows you to turn a healthy mode on. And once you do that, you can see that it kind of filters out the results. And it's kind of up to you how you want to implement this. This is specific to a use case. We just have a field that gives a health rating randomly. And that's what kind of filters out these restaurant results. And as far as the disruptor itself is concerned, it's also, again, up to you and up to your use case how often and when you want to trigger this. So, for example, you could trigger it if a user is ordering from the same restaurant a bunch of times, right? Or if he's ordering from the same type of restaurant a bunch of times. That's probably when you want to trigger this. And that's also where an interesting thing comes in, which is about being pushy and giving the user control, right? If I'm ordering pizza 6 days in a row and I see this, I'm going to be like, who are you to tell me? Right? It's kind of up to you. It depends on the users. Although I probably need a healthy option. I know you're thinking, no, but you look great. But that's because I'm wearing Spanx right now. Spanx for men, right? Who would have thought? I can't feel my legs, I can't breathe, but hey.
You look great.
I look great, exactly. So, coming back to our presentation, let's now that you have an idea of the how, the what, and the why, let's look at some of the not so pretty aspects of predictive UX.
Yeah, so to really wrap up this talk, we want to just talk about some of the privacy concerns and ethics considerations that you really want to be, I think you should be thinking about. Powerful technology like this should really be, I think, discussed, and this is something that's pretty new, I think, at least to the open source community. And I think it's really important to talk about. So, big data has been a really new frontier with pioneers making their own rules, as they must, as you're exploring. But as we forge ahead, I think we have a responsibility to maintain empathy for our users and make sure we're not creating systems that are going to be malicious or hurt them, especially when it can so deeply impact their lives. I think right now, from a privacy standpoint, there's a couple of things that are causing trust issues, kind of timely, like all the stuff that's been in the news about Facebook lately with like personal data being stolen or sold on the black market. Trackers are profiling us and following our every move, which is a little bit creepy. I actually had this happen two weekends ago where I was having a conversation with a friend about a pair of rose pink tennis shoes that I owned. She had never Googled them, never searched for them online ever. And the next day she sent me a screenshot of her Instagram and she had an ad for rose pink tennis shoes in her Instagram feed. This isn't the future, this is right now. And I really think, we're also forcing users to sign unfriendly privacy policies. I was reading a stat that if you try to read every single privacy policy that is given to you on average throughout a year, you would probably spend about 88 hours reading those. I don't think anyone has time for that or is actually even thoroughly reading those through. So I think we, just could be a lot better at being a little bit more transparent about what we're asking people to agree to. So, like I said, this isn't something that's super far away. It's happening right now. I think predictive UX is really the next horizon. We have a lot of clients asking for personalization. They're talking to us about products like marketing, Marketo AI. This is definitely something we're starting to see an interest in from our clients, and we're in the B2B space. So I think the stuff that we've shown you has been very focused on B2C because I think that an application right now is a lot easier to do because you have a lot more opportunities to collect very explicit conversion points. Whereas more of a B2B marketing site, it's a lot more implicit data that you're collecting. You're not necessarily always going to be there's no products necessarily for someone to buy on a site like that. So but I think people will start figuring some of that stuff out, and it's just going to start becoming more powerful. So, responsive was back in the day, that's pretty much become a standard. I think this will become a standard and probably within the next decade or two. So, yeah.
And before we end, we wanted to give a shout out to Joel van Bontegraven. How do I want to say that name? But the book is called Introduction to Anticipatory Design. It's one of the very few resources that we found on the topic. Well written, it's not a long read, it's very interesting, and it's available online for $10. So I highly recommend it. And we would also like to acknowledge our colleague who couldn't join us here, Aubrey, who helped us make the demo site look nice. This is a list of our references and the development tools I was talking about. And we will be uploading these slides on the Barcamp site to make sure that everybody has access to these. All of these things here have excellent documentation. I read through the documentation and I tried to get things set up, and I didn't really face any problems. An interesting thing I will point out is that I did come across issues where I was running out of memory every now and then with my machine learning engine, so that kind of showed me that there's more to consider and it's not all that easy as it looks, so there are some limitations. A couple of interesting reads that we found, and these relate to the UX principles that we saw. Highly recommend them again. We won't go into them right now. And so hopefully that gives you some material to think about and start the conversation, kind of explore on your own and see what you find. And we've also given you a lot of information here, so we do want to keep plenty of time for questions. So fire away. Any questions, comments, suggestions? Please do.
Prediction UI pretty much work like Drupal analytics. You've got a script that's loaded every time the user hits the page.
Okay, so the question is if Prediction IO is like a Google Analytics script and that it's loaded on every page. So it's not. It runs as its own server process. And in my case, I'm actually running it completely independent of the Drupal site. And you can, so it's on its own server basically. And you can kind of like send API requests the way you would communicate with any other server, but there isn't a script that's running now. Yes?
On your demo site, which was really cool, by the way, I noticed that you had to log in and authenticate as a user.
Right.
Is it possible, or have you run across anything that doesn't require that level of authentication, but can actually predict based on other factors, or even just how someone might be browsing your website?
Mm-hmm. So the question is if the users, do the users have to authenticate to get personalization, or can it be done by other factors, right? So again, yes, it can. We picked the easy route because that's the easiest way to do it, to have them authenticate to your site. But that's where the explicit versus implicit comes in, and there is so much implicit data that you can gather from just a browser. A user's browsing history, their actions around your site, like you said, and there are already tools that help you track that, of course, with consent.
You can actually get information on what hardware they're using,
Right.
which is kind of weird. I don't know why you would need to know that, but, but you can just get
Good
that.
question.
Yeah.
So you can use implicit data like that. Just a little more processing, a little more thought that needs to go in that we didn't have the time for this demo. Go ahead.
Has the concern of ethics ever come up while you've been working on projects?
Oh yeah, so the question is if the question of privacy concerns and ethics come up when we are working on projects.
So this is definitely something that our company is starting to work more on, like on a personalization level, sort of like internal R&D type of stuff. It's not something that we're currently doing actively with our clients at this scale. So I think what we are doing a lot more of is personalization in particular. And that hasn't really come up yet just because a lot of the tools I think we're using aren't so powerful yet. And it becomes very obvious that users are starting to be, at the point that a user is starting to be tracked, I think they're a little bit more aware of it. It's not necessarily like this hidden thing. A lot of the data that we're collecting right now is being done through what we refer to as micro surveys. So a user's actually having to put in explicit inputs for us to collect that data. So they know that they're essentially taking this survey or quiz and filling out a form. So that's not something that we've really come up against yet, but I could see that it could in the future for sure.
That was a great question, though.
Yeah.
I think that's something to keep in mind as we move ahead. Yes, please go ahead.
Great presentation, thank you.
Thank you.
I'm curious, to me the most obvious examples of this in use have to do with probably commercial plans who buy stuff,
Right.
food apps and stuff. Where else is this being used, outside of commerce?
So the question was, where else are these kind of systems being used outside of the commercial space? That's a good question, and I actually haven't personally seen a lot of places where this is used. I know some B2B tools that do give you some, like a level of this, but not quite to that extent. But like I mentioned, I think the commercial space is right now filled with recommendation systems for the most part. The rest of the machine learning techniques are kind of more in the academic space so far. I don't think they've seen so much exposure.
Yeah. And again, I think part of the reason why it is mostly seen in the commercial space is just because, one, it's very powerful in that context, and so I think people have put in a lot of effort in how to do that. And two, like I said before, you get those very explicit conversion points where someone's clicking on a product or purchasing a product. It goes to it's a lot more account based, so you're able to very easily track that data. And I think in more of a business to business aspect, it becomes more challenging because you don't necessarily have that. You're really relying a lot. It's a much heavier lift, and you need a lot more incentives for people to actually maybe sign up for an account or give you their information. And I think that's definitely something we, Gerwinder and I both, and as a company, are really interested in exploring more. Is how do we make this work more for B2B? I think there's Gerwinder was saying, there are products out there like Demandbase, which is a really powerful data collection engine that is starting to do some of this and starting to sell that. We're doing some personalization stuff on our own site, where we actually are able to serve very targeted content to users, but it doesn't yet have a predictive. It doesn't have machine learning behind it yet.
I think education, primary education, with secondary research, you can really pull a lot of data about students' behavior and use patterns.
Yeah, definitely. Anything that has, do you mean feeding it in, or just having users actually interact with something to get it?
The teachers, the size of the classroom, the teacher is not able to customize.
Yep.
That's a good idea. And the suggestion was to use this in the education field and collect data for students and teachers.
Yeah, absolutely. I think that could be really powerful. Yeah, definitely. And you can, the way you collect the data, there's probably myriads of ways, but you have test scores, you have students enrolling, there's a lot of stuff there. So yeah, I think that could be a really good context for something.
That's a good
like
idea.
this. Yeah.
There was a question in the back.
Yeah, so one of the things on the educational thing that we've been considering, but have ethical issues on course selection for students. And based on your history, gender, and ethnicity, we could actually present recombination of courses that you would most likely do well in. But then there's a lot of ethical questions on using those variables to make predictive analysis.
Right.
Yep.
It gets a little messy.
Oh yeah, I will repeat that. So the comment was that in the education industry, an example application is using a student's characteristics to suggest courses for them, but that gets into a really complex situation with ethics and profiling and things like that.
Yeah, I think that has a lot of psychological questions behind it too. Because you're making these recommendations for basically, it's here's how you can succeed. It takes a lot of that that decision making out of that for people, and it maybe allows people to opt out of a more challenging, more rewarding path. Yeah, I think that's a really interesting ethical conversation to have. Yeah.
Or you can just put on Spanx and look good.
Go ahead. We'll suggest that.
One more question in the back.
What does emotional intelligence look like in a machine?
That was Lauren, take this one.
Yeah, the question was, what does emotional intelligence look like in a machine? I think that's sort of the idea of the master algorithm. It's true AI, I think, and there's actually not even related to this. I read this book called Elastic that talks a lot about this, and it talks about the idea of analytical thinking versus elastic thinking. And analytical thinking is the very traditional sort of way that most of our society operates. It's very linear. That's how computers are programmed. That's how they function. But human beings themselves have a huge capacity to be elastic. That's just sort of how our brains work. And we've been trying to replicate that in machines for as long as they've been around. And I'm struggling to find like a very specific answer for you of like what that would look like. I think it would be like I read a case study where there was like some kind of like event. I think it was like a terrorist event somewhere in Africa or Australia. I can't remember exactly what region in the world. It was like Southeast Asia or something, where the people were trying to get out of the area like super fast, and they started calling Ubers. Well, all the Uber algorithm saw was that there was a surge in people wanting rides. So they, what does the algorithm do? It uptakes the cost of those rides, and it has no capacity to adapt for the situation. And I think they got a lot of flack for that because they're like, wow, like we have this tragedy and you guys are charging extra for people to get rides out of the area. Like, that's so inhuman of you. But like, it wasn't a human making that decision, right? It was a computer making that decision. It was doing exactly what it was programmed to do. So I think what does emotional thinking look like in a machine is it has the capacity to adapt to those types of scenarios. And I don't think we're there yet.
And I can give you another example. Microsoft had a bot on Twitter. I forget the name, but you must have seen it in the news.
Yeah.
Yep. And that bot turned racist, sexist in a matter of days because of what it was getting. So I think the point where we can tell a machine that, hey, this is right and this is wrong, kind of teach it how you teach children, I think that's what emotional intelligence would look like in a machine. Go
I
ahead.
think you might have to teach the machines to be cynical, and that might be true.
I agree. Any other questions? All right.
Sure. Yeah,
We
thank you so much.
Thank you again for joining us. We hope you have a great time.
Oh, wait. No, you can edit. I was just like, don't forget.